Okay guys, so today we're going to start talking about something called a mole ratio. You're going to need page 6 in your packet. You actually do not need a periodic table today, big surprise, but you do need a calculator so you can follow along and do the calculations. So last class we started talking about something called the mole. And we said that we use the concept of the mole to be able to count out atoms. We can't actually physically count atoms, so we have this big group of atoms that we can weigh called a mole. Now, when we've got our chemical equation, so here's my balanced chemical equation. My balanced chemical equation is my recipe for how much of each ingredient I need to react. It's also my recipe for how much of each product is going to form. And so we spend a lot of time figuring out how to determine those coefficients that go in front of my balanced chemical equation. Today we're going to see how we use those to change from one ingredient to another ingredient, or from one reactant to a product. Okay, so we're figuring out how to change one thing to something completely different. So in problem 1A, I'm told that I have 8 moles of magnesium chloride. I'm told that it is reacting with enough aluminum, so I'm not worrying about aluminum, I've got enough, and I want to figure out how many moles of aluminum chloride I'm making. Now, just like last class, I'm going to set up my problems the exact same way. So I'm always going to start with my number given. So I've got 8 moles. Now it's really important that because I'm changing from one element or compound, that I'm keeping track of what it's 8 moles of. So I was told it's magnesium chloride. This is my magnesium chloride. Okay. Now, just like last class, whatever unit I'm starting with in the beginning of the problem, I'm going to write on the bottom of the line so that it will cancel out. Just like last class, whatever unit I'm changing to, I'm going to write on top of the line. So I'm changing to moles of aluminum chloride. This is my aluminum chloride. So that's going to go on top of the line. Okay. Now this is where it's different than last class. Last class I was looking at the periodic table, I was using Avogadro's number, I was seeing how things change. For mole to mole, the only place I'm looking is this balanced chemical equation. The balanced chemical equation tells me the ratio of how much magnesium I need and how much aluminum chloride is going to form. So all I do is I look at the balanced chemical equation, I find MgCl2, that had a 3 next to it in the equation. So I'm going to put a 3 right there. I find aluminum chloride in the equation. It had a 2 in the balanced chemical equation, so I'm going to put a 2 right here. So this number came from the coefficient in front of AlCl3. This 3 came from the coefficient in front of MgCl2. This ratio is called my mole ratio. Okay? Now, just like last class, any number on top of the line, I multiply. Any number on the bottom of the line, I divide. So when I put this in my calculator, I'm going to take 8 times 2 divided by 3, and I should get 5.33 moles. Now, my moles of MgCl2 went away, So I should have moles of aluminum chloride. Okay? So let's take a second and try question B. So in question B, I'm asked how many moles of magnesium chloride, whoops, wrong color, moles of magnesium chloride, this one, are going to be needed to react with moles of aluminum. So here's my aluminum. So pause the video, take a second, and try to solve this out. So what we should have done is I was told that I have 10 moles of aluminum. I always start with the number given. Because I'm starting with moles of aluminum need to go on the bottom so that they can cancel out. I was told that I'm changing to moles of magnesium chloride, which should have been yellow. So that goes on top. Now, just like before, when I'm changing from moles of one element or compound to moles of another element or compound, I need to look at my balanced chemical equation. So MgCl2 is going to get a 3 in front of it. Al is going to get a 2 in front of it. When I plug this into my calculator, numbers on top I multiply, numbers on bottom I divide. 10 times 3 is 30, divided by 2, I should have gotten 15 moles. Aluminum canceled out. I was left with magnesium chloride. Okay? So take a second. Let's try 2A. 2A, I'm using this new balanced chemical equation. I'm told that I have 7.5 moles of hydrogen. And it says how many moles of nitrogen are needed to react. So take a second, pause the video, solve 2A. Hopefully, what we should have gotten was 7.5 moles of hydrogen. Draw my time sign, my line. Because I'm starting with moles of hydrogen, I need to make that go away, so that goes on the bottom. I'm changing to moles of nitrogen, so that goes on top. Okay. Now, when I'm changing from moles to moles and I look at my balanced equation, I need to remember, if there's not a number in front, there's no coefficient, I know that that number is a 1. So I had 1 mole of nitrogen, 3 moles of hydrogen, plug it into my calculator, 7.5 times 1, divided by 3. Hopefully, we all got 2.5 moles of N2. Okay? Now you should be able to solve B and C relatively easy. Question 3 is going to be a little bit trickier. The problem with question 3 is they don't give me a balanced chemical equation. And without a balanced chemical equation, I can't do this. So before I try to solve A, B, and C, I need to come up with an equation. So I'm told that I have combustion of methane, and that methane is CH4. Hopefully, I remember from the last unit that combustion is burning. I know that anytime something burns, I need oxygen to make my fire go, and that oxygen is always a diatomic molecule. He exists as O2. Now for combustion reactions, hopefully I remember that I always make the same two products. Combustion always makes carbon dioxide and water. So any combustion reaction always has O2 as a reactant. It always has CO2 and water as products. Now, right now, this equation isn't going to help me because I still don't have any coefficients. I cannot change from moles of one element or compound to another without a balanced chemical equation. So let's check and see what we need to do to fix this. 1C on the left, 1C on the right. I'm good to go. I'm going to leave that alone. 4 H's on the left. Uh-oh, only got 2. So I need to put a 2 in front there to balance that out. 2 times 2 is 4. Now my H's are good. Unfortunately, O's are a little bit trickier. I've got 2 O's in CO2. I had 1 O in H2O, but I multiplied it by 2. So now I've got 2 here. They're separated by a plus sign. 4 O's total over here. So I need to multiply this 2 by 2. Okay? So this is my balanced chemical equation that I will need to be able to solve 3A through C. Okay?